knowledge base, then all the actions schema will also have prepositions. They won't have predicates. Okay. Now the next thing that I need to remember over here is, I'm not going into this detail. We are going to check these particular two differentiation points, and this is a good question for any sort of internal test question or an Viva oral questions. Although ADL is not there in your syllabus, STRIPS is there. So we are listing out important points where STRIPS scores over ADL. So ADL stands for, I had given you what it means yesterday. It is abstract data representation language or something like that. STRIPS, we know what it is. It is Stanford Research Institute problem solver language. Okay, we only use positive literals, poor and unknown. We may have positive and negative literals mixed in ADL. So that's the beauty of ADL. We can mix positive and negative literals together. STRIPS has closed world assumption. That means unmentioned literals are false. And in literal I don't mention in the state representation is always false. ADL on the other hand does not say or does not assume the closed world assumption. So for it, the world is open. The literals which are not known or which are unknown, their truth values are also unknown. Unmentioned literals are completely unknown. Their truth value is not known. Effect P and not Q means we need to add P and remove Q from the state representation. Effect P and not Q means add P and not Q and delete not P and Q. So now it's natural that in ADL we are doing extra operations than strips, because both say are generating effects P and not Q. In strips I just need to add one thing and delete one thing. On the other hand, in ADL, I need to always do take care that both the assertions P and not Q should be added, and their negated versions, not P and Q, needs to be deleted. So extra operations are there. Fine. Then in strip language, only the ground literals are there in the goal, whereas in ADL, we can have variables and quantified predicates as well in the representation of the goal. So यहाँ पे एग्जाम्पल दिया हुआ है स्ट्रिप में जो प्रपोजिशनल गोल का एग्जाम्पल है, इसका मतलब ये नहीं कि स्ट्रिप्स में प्रपोजिशनल गोल होते हैं, लेकिन प्रपोजिशनलाइज्ड प्रेडिकेट्स भी हो सकते हैं गोल में in the strip language. Please understand that goals are always conjunction in the strip language, whereas goals allow conjunction and disjunction both in ADL language. That's another thing that ADL allows. So strip is a in this particular issue or in this particular property, ADL scores over strip because ADL is now able to represent more things easily because we are allowing two different connectives, which means that a lot of things can easily be encoded, like implication, like bidirectional. Because if I want to have implication realized or represented, then in ADL, I can directly apply the implication removal formula and I'm done. But not that much, that easy for the strip language. Okay. Next thing is that effects are conjunctions. So effects are always conjunctions in the case of strip. Conditional effects are allowed in ADL when P colon E means E is an effect only if P is satisfied. So precondition P is satisfied, then only E is the effect. So there is no way to represent equality in strip language because we are not having variables as such. But in ADL, that is possible. So it is more closer to a generic representation, ADL. There is no support for types in this strip, whereas ADL, there is a way to represent different types for different objects in ADL. Okay, so that's the difference between two representational languages, ADL as well as strip. Now, this is an example of an action in represented in ADL. So we are saying action fly P colon P plane. So here we are directly saying that P has a type plane, from has a type airport, to has a type airport. So considerably number of Number of things that we had there and it together will now get reduced, because we had to say that P is a plane precisely in strips. Here we are saying that P has a type plane. So there is some kind of an aggregation relation that we are defining, and that is making our, that will make our lives easy. Okay, ADL is not there in your syllabus, so don't worry about what it means, how it is written, and will I be required to write things in ADL. Okay, so the full form of ADL is action description language. Okay, so we describe action. So just for your information, preconditions here is that P should be at from, and from should be different from to, then I can fly from P to. Now this was not the case, or this I could not do in case of strips representation, because there was no way to check whether P the from and to are equal or not. Okay, fine. Now the effect is also realized in a different manner, so resultant will also be different. So there are many different planners available. So this is planning domain definition language, or PDDL, another variant language which is not there in your syllabus. So EDL, PDDL are not there in your syllabus. This is an important thing. This we'll leave our lecture today at this point, and we will talk about this tomorrow. So I am going to leave you with 2 minutes looking at this particular slides at the end of this recorded session. As I told you, I'm not going to have a full lecture. I am just taking forward the topic, and I don't want you to lose interest. That's the important thing I'm doing over here. So see what we have here is, we have init, means this is an initial state, and this init starts at this point and this ends over here. Okay, this init has 1 2 3 4 5 6 7 8 9 10 predicates, which says C1 SFO is at SFO, C2 is at JFK, P1 is at SFO, P2 is at JFK, T1 is a cargo, C2 is a cargo, P1 is a plane, and P2 is also plane, JFK is an airport, SFO is an airport. So now this naturally is a cargo transportation problem. There is some cargo at a particular airport, and there is some other cargo at some other airport, and we want to move a particular cargo from one place to the other. So what we want as a goal state is C1 should be at JFK. So C1 cargo, which is currently at SFO, should go to JFK, and C2 is the cargo which is currently at JFK, should come to SFO or San Francisco. So I need to fly the cargo from SFO to JFK, and cargo C2 from JFK to SFO. So that is what a normal person or a human being can understand from this. Now, for doing so, I need to define action schema. And my action schema will have over here, I guess, 1, 2, and 3 actions. So I have defined 3 actions over here. Okay, the first action is the load action, which loads a cargo in a plane at an airport. So I load a cargo C in a plane P being at an airport A. Okay, so this is what we do in the load action. Unload action, we remove cargo from plane P at an airport A. So now when I want to transport cargo C1 from SFO to JFK, I need to first load cargo C1 in the plane which should be present in SFO, and then we should fly the plane from SFO to JFK. So I need load action, then I need fly action. Once I reach the destination or destined airport, I can unload the cargo. I can unload the cargo. So load, unload, and fly. These are the 3 possible actions that I require. Now the rest of the things are in front of you. I leave it with you what these things are and how these preconditions are defined. Things to note or things to remember based on the discussion done today is the init, or the initial state that I have represented. So init is the name of the state, and all the other things which are conjuncted together or anded together are nothing but the predicates, and all you will check that all the predicates are grounded one. That is, the parameters are ground terms, be it binary predicate or unary predicate, irrespective of that. Now, the second part of my definition of planning problem is the goal. So the goal is defined as conjunction again of multiple ground literals. We are again having ground literals over there in the predicate. So ground terms are there or atoms are there. So since there are atoms, I can modify them. So at C1JFK is an atom, at C2J SFO is an atom, and they are ANDed together. And that is something like a subset of the all atoms that make up a state. Fine. Then we talk about actions, and actions we are evident that in the name itself of the action and the parameters of the action, we are using variables. There are small case letters CPA, and P from 2. So we have already learned about action fly P from 2. This is exactly the same action. We generate delete list and add list in the effect. Okay, effect also can have variables, precondition also can have variables, and the action name can also have variables. Okay, fine. So we will stop here. I hope you will be able to understand the content that I have discussed right now. I hope you will look all the 3-part session that I have recorded before tomorrow's lecture. So tomorrow we'll be having lecture. I'm not traveling tomorrow. I'm at home tomorrow. So tomorrow we will be positively be having lecture at 2 o'clock. So before that lecture, I would request you to watch these 3-part video or 2-part video, whatever it is composed of, so that things will be easy for me as well as you to understand. Okay. Thank you.